Let's take a look at some of these physics application problems. And for this very first question, we have a particle that moves along a straight line, and our goal is to find the displacement and the distance traveled by the particle given the time interval. So our time interval is from 0 to 2 seconds, and our velocity function is v of t equals to t squared minus 1. So for this particular problem, all we're really trying to do is making sure that you understand how to input the time values and your velocity function into the formulas for displacement and distance traveled. So here is our displacement formula right here. It's the integral from a to b of your velocity function with respect to t. And all we have to do is just input the numbers into this little formula here. So your lower bound is going to be 0, and your upper bound is going to be 2. So it's going from 0 to 2. And your velocity function is t squared minus 1. Now I'll put that in a bracket, and we are integrating with respect to t. And all you have to do now is just plug that into a calculator, and you should get the value of 2/3. So the displacement for the first 2 seconds is going to be 2/3 by this particle. Okay, and for the distance traveled here, our formula for the distance travel is the integral from a to b, but this time we're taking the absolute value of your velocity function with respect to t. Okay, so once again, all we have to do is just input the numbers into this little formula here. So our lower bound is going to be 0, our upper bound is going to be 2. This time we're going to take the absolute value of the velocity function, which is t squared minus 1, and then we finish off the absolute value there, and we're integrating with respect to t. And once we plug that into a graphing calculator, we get 2. So the total distance traveled is 2. Okay, one skill that you might want to work on is just making sure you're inputting this into a calculator correctly. So this is what you would input into Desmos for your displacement, and this is what you would input into Desmos for your total distance traveled. So absolute value, just type in the words ABS, and there you have it, 2 and 2/3. Okay, let's move on to another question here. Okay, so same question here. We need to find the displacement and the distance traveled given the time interval from 0 to 5 pi over 6. So as soon as you see the 5 pi over 6, make sure your calculator is in radian mode. And if you want to find the displacement is d hat equals to the integral from a to b of your velocity function dt. So there's your displacement formula. And we're just inputting the numbers in here. So our lower bound is going to be 0, our upper bound is going to be 5 pi over 6, and our velocity function is 2 cos t, and we are integrating with respect to time. And if you want, you can put brackets around your 2 cos t. Okay, after that, you would just go to a calculator here, and this will give you a value of 1. So our displacement from 0 to 5 pi over 6 is going to be 1. And if I want to find my distance traveled, the distance formula is the integral from a to b, but this time we want the absolute value of your velocity function of 2 cos t. All right, and then we can close that absolute value sign off, and we are integrating with respect to time. Okay, so that's our formula for our total distance there. And once again, this is your velocity function here, and what we're going to do now is we're just going to input the numbers in. So we're going from 0 to 5 pi over 6. Absolute value of 2 cos t. Close that off with respect to dt. And on your calculator here, you should get a value of 3. So when you're using your calculator, this actually helps speed up the process quite a bit. If you had to do this algebraically, you would probably have to set up 2 integrals, and it would take quite a bit of work using the fundamental thermocalculus. Okay, and just before we finish off that question, here we are. Here are the answers. This is how you would input your work into a calculator. So if you're using Desmos, for example, you would input the work like this, and this is your displacement 1, and your total distance is 3. Okay, let's move on to, let's flip the pages here. Let's move on to another question here. So using a graphing calculator here, we now have a situation where a particle is moving along the s-axis, and we're given its velocity function as this, e to the power of sine t minus 1, and the domain is when t is greater or equal to 0. And we're also given that the position of the particle is 2 when time t equals to 0. So what that really means is that when time equals to 0, the position of the function has a value of 2. and I want to find the position of the particle after 4 seconds of travel. Okay, so basically we're looking for the final position of the particle after 4 seconds, and we do have a very nice formula for that as well. So your final position, which is S of B, is equal to your initial position at A plus the integral from A to B of V of t dt. Okay, so just like in the previous question, we mentioned that this right here is your displacement. This is your displacement. S of A is your initial position, and S of B is your final position, right? So this is your initial position, and this is your final position. So this is a very nice little formula that we can that we've went over in class, and we can apply this formula to find the final position of this particle after 4 seconds of travel here. And remember, the general formula for displacement is really your final position minus your initial position. And all we're doing is we're just rearranging this formula right here to get to this statement right there. So this question is really just inputting numbers into a formula. Okay, now that we've established that, let's go ahead and just plug the numbers in. So I'm going to find the position after 4 seconds. And our starting position has a time value of 0, so S of 0 plus the integral from 0 to 4. And our velocity function is e to the power of sine t minus 1. I'll put this in brackets, and we are integrating with respect to time. Okay, and then after that, you want to go to a calculator. Sorry, not a calculator, but S of 0 right here has a value of 2, as we established at the beginning of this problem. So this would be 2 plus this integral right here from 0 to 4. Of bracket e to the sine t minus 1 dt. And if you do this, this will be 2 plus, and this part right here roughly should be around 2.796. And if you add those two numbers together, you should get 4.796. Okay, so there's your final answer right there. And just before we finish off, I just want to give you a little, this is how you would input the question into decimals right there. So this 2 right here, that's your initial position. And this right here is your displacement, right? And you get an answer of 4.796, rounded to 3 decimal places. Okay, last question here. Let's move on to the next physics application problem. And for this particular problem, we have a particle that moves along a straight line, and we're given the acceleration function as a of t equals to 2 cos bracket t plus ln t for time as t is greater or equal to 0. And the velocity of the particle is 3 when time t equals to 1. So this is kind of like your initial velocity. And we need to find like the final velocity of the particle after 5 seconds. Okay, so for this particular question, the idea is really coming from the concept of a change in velocity. So when you have a change in velocity, this is really your final velocity minus your initial velocity. And if you rearrange this formula here, your final velocity is really going to be your initial velocity plus your change in velocity. And now we can keep on deriving this formula. So your final velocity is equal to your initial velocity plus delta v. Now delta v, this is really a change in velocity. And for calculus, this is really the integral from a to b of your acceleration function with respect to time. And if we apply the fundamental theorem of calculus right here, the antiderivative of acceleration is really velocity. So this really equals to v of b minus v of a using the fundamental theorem of calculus, which is really the concept of a change in velocity, right? So it's like your final velocity minus your initial velocity, right? So for this question right here, our goal is we'll be using this little formula here that we derived to kind of answer our problem here, because we need to find the final velocity of the particle after 5 seconds of travel. Okay, so let me kind of rewrite that formula again over here. So if I change this into calculus notation here, the final velocity is really v of b equals to your initial velocity, which is v of a, plus the integral from a to b of your acceleration function. Okay, so a little bit of work there to kind of set up that integral. But now the easy part is we just kind of plug the numbers and functions into this formula and just jump right to our calculator. So our final time is 5, so we want to find the velocity after 5 seconds. And we're given our initial velocity at time t equals to 1 is 3, so this is v of 1, plus the integral from a to b, which is from 1 to 5. And our acceleration function is given to us over here, which is bracket 2 cos bracket t plus ln t, close that bracket, and we're integrating with respect to time. Okay, so now we just need to plug in the numbers into our formula, and then we've got this. But what's v of 1? Well, v of 1 is given to us as 3 at the start of the problem here, so we can just input that in right away. So let me erase this and type in 3. And then after that, we can jump to our calculator and get the right answer here. And if I go to a calculator, I should get a value of 2.546. Okay, so there's your final answer right there. And if you are going to Desmos, this is how you would input this into a Desmos right there. So there is your initial velocity at v of 1, which is 3. This is your final time at 5, and there is your acceleration function, and that right there is your answer. So just round that to 3 decimal places.